In this video, we'll review how to solve literal equations. Literal equations are equations with multiple variables. A literal equation is an equation where the variable can represent a known value. This allows us to write equations to represent values like distance, rate, time, energy, mass, perimeter, area, or any other number of variables that we might be interested in. Now here's some common literal equations that you might know. The area of a triangle is 1/2 of base times height. The perimeter of a rectangle is 2 times the length plus 2 times the width. The distance formula, where distance equals rate times time, or even Einstein's energy equation for the theory of special relativity, E equals mc squared. Now let's take a look at that first example. Area equals 1/2 base times height. The area of a triangle, 1/2 the product of base times height. Now, what if instead of wanting to know how big the area was, what if we want to know how long the base of the triangle was? That is, in the formula, I want to solve for b instead. I want to get b by itself. What would it take to get b by itself, to isolate the b? Well, here on the side with b, we've got 1/2 times b times h. That means we're going to need to undo the 1/2 and undo the h. Multiplying by 1/2 is the same as really dividing by 2. So we need to undo dividing by 2. The inverse of dividing by 2 is to multiply by 2. So we can begin by multiplying both sides by 2. This gives me 2a equals 2 times half of b times h. Well, multiplying by 2 and dividing by 2 cancel, so 2 times half cancels, and it leaves me 2a equals base times height. But I haven't isolated b all the way, I still get the h. We're multiplying b times h, so the inverse of multiplying by h would divide by h. So we can do this now by dividing both sides by h. This leaves me 2a over h equals, and now my b. I've done it. I've isolated b, and I've solved for b. The base of the triangle is 2 times the area divided by height. Now let's take a look at a couple more examples. Let's look at the perimeter formula. What if instead I wanted to solve for w? I need to isolate the w or get w by itself. I had the perimeter equals 2 times the length plus 2 times the w. Well, to get w by itself, I can undo my addition first. This means instead of adding 2l, I'll subtract 2l to both sides. I get p minus 2l equals 2w. And I almost got w isolated, but it's 2 times w. To undo multiplying by 2, we can divide by 2. This means we divide both sides or everything by 2. This leaves me p minus 2l over 2 equals w. Now I could divide a little bit and simplify it. I could say p over 2 minus 2l over 2, which would really give me p over 2 minus 1/2 of l. Sorry, that would be p over 2 minus just l. But I think we can just leave it like this instead. Now for the next one, I need to get r by itself. In order to do this, I need to undo the n and the t. And I'm just going to pick one to start with. Instead of multiplying by n, we'll undo it by dividing by n. This leaves me pv over n equals, on the other side I still have rt. To get r by itself, I still need to get rid of the t. The way to do that is to divide. Instead of multiplying by t, we'll divide by t. Now I'm already dividing by n on the other side, which means now I'm dividing by both n and t. This leaves me pv over nt equals, and on the right-hand side, now just r. I've got my variable by itself. r equals pv divided by nt. Now I've got 3 more examples here. I'd like for you to pause the video and work them out, and then resume the video to check your answers. I'll give you a moment. Alright, hopefully you've had a chance to work it. For number 1, we want to isolate the b. We had 2b plus c equals d. We'll start by undoing the adding c. Instead of adding, we can undo it by subtracting c from both sides. This leaves me 2b equals d minus c. Now to undo the 2, the inverse of multiplying is to divide, so we'll divide both sides by 2. This leaves me b equals d minus c over 2. Or b equals d over 2 minus c over 2. For number 2, we want to isolate the a. Here we had a plus c divided by -3 equals d. So this one we're going to have to undo the division first. The way to undo the division is to multiply, so we'll multiply both sides by -3. This leaves me a plus c equals negative 3d. And I'm almost got it, but I still got c on the wrong side. To fully isolate the a, we're going to undo the plus c, which means the inverse of adding c would be to subtract it. So we'll subtract c from both sides. And now we get a equals 3d minus c. For our last example, we need to get the c by itself. Well, we could either distribute the negative 5, or, because it's on the outside, we could just divide both sides by negative 5 to start with. So let's do that. This leaves me b minus c equals d plus e all over negative 5. To fully isolate negative c, we're going to subtract b from both sides. But this leaves negative c equals d plus e over negative 5 minus b. Now I can either multiply both sides by negative 1 or divide by negative 1. But because I already have division on the other side, that would be kind of messy. So instead, I'm just going to multiply both sides by negative 1. Distributing the negative 1 on the right-hand side, I get c equals negative 1 times the d plus e all over negative 5, which means negative 1 and negative 5, the negatives cancel. It gives me d plus e over 5. And then negative 1 times negative b is positive b. So this means I get c equals d plus e over positive 5 plus b. That one's pretty tricky with the minus signs. You got to watch what you're doing there. All right. Thank you for watching this video, and hopefully it helps you to understand how to do literal equations.